Okay, now let me talk about the states of matter as you may have remembered it from middle school, and we talked about solid, liquids, and gases. You may recall that solids have a definite shape. So this marker has a definite shape. It's a solid, and when I put it in the container, it has a definite volume, but it has a definite shape. It doesn't take on the shape of the container. It's just kind of flopping around in there. Right? Now, liquids do not have a definite shape, but they do have a definite volume. So if I measure a certain amount of blue liquid in my graduated cylinder, here it looks like about 180 milliliters. When I pour it into a different container, I still have 180 milliliters, but now the shape of it is in the shape of this container, the glass. Now, gases, they don't have a definite shape and they don't have a definite volume. Gases will expand, they will diffuse in a room to fill the volume of the container. So I like to talk about when kids come into the room and I just have replaced my air freshener, they smell the air freshener when they first come in the room, even though the air freshener is right around the corner. Now, how does that happen? Well, the gas, the aroma that's coming out of the air freshener fills the entire room. The little smelly particles, whatever they are, they get in every corner of the room because the gas fills. Now, in terms of the kinetic theory, I want to make the connection to what we have learned about kinetic theory. Solids are particles that are closely packed together. They're not moving around very much. Liquids are allowed to kind of slide past each other. Here I'm going again with the hand jive, right? So we have solids, liquids, and then particles that are gases, they are so energetic that they actually are free of the bonds that kept them together, and they actually try to get away from each other and they spread out, right? So solids closely packed and not moving very much. Liquids can slide past each other and take the shape of their container, and gases are so energetic that they fly apart. There's one more state of matter that we need to be aware of. Plasma is the fourth state of matter. It's basically a gas, but it is highly energetic. These are hot particles. It's the stuff that stars are made of. It is the most abundant state of matter in the entire universe. We do have plasma here on Earth, and you can see an example of that in the lights right above us, the compact fluorescent lights. Those are basically a tube of gas that we pump a lot of electricity through. Well, that electricity energizes the gas. It energizes it so much that the electrons are stripped away from the atoms, and so we have these positive ions and these electrons running around, and then when the electrons go back to the atoms, there's a photon of light that's released. Well, I've talked a lot about atomic theory and things like that just to tell you what a plasma is, but suffice to say that very energetic hot particles, actually it's like the kind of particles that are involved in a nuclear explosion. Our sun is a nuclear bomb going off. Our sun is a plasma, and most of the universe is suns and stars, and so that's why plasma is the most abundant state of matter in the entire universe. I hope I've made a connection for you between what you already know about states of matter, solid, liquid, and gas, and I hope I've made that connection to our kinetic theory.